Okay, number one, it wants to know which of the following functions has a graph of y equals the square root of x that is shifted down 3 units. Okay, so we need to know, what does that mean? So if you compare this, the k is the value that goes up or down. So I'm looking for something at the back, and a negative will shift it down. So I'm looking for a minus at the back. Okay, so this is different from being underneath the square root. That will be the same effect of h. So in this one, down would be a -3, but we want it on the outside at the back. All right, question 2, we have a number of graph or equations to choose from, and we want to match those up with the graphs that we see below. All right, so one thing you want to be aware of is the graph of the parent function. Let me see if I can go back to Blackboard. And you can see the parent function in either the plus version, or we can also see it, let me go back, in just the original version. And I'm going to pull this one up. It's a lot less complex. So right here, top left, we see x squared, just a regular parabola. The center always starts on 0, 0. And it looks a little bit different when we compare it to this version here. So if I'm looking at this version, it looks as though this graph has moved up. So that center point is no longer here, it's moved up 1, 2, 3, 4, 5, looks like 6 places. And also the graph is flipped, it's going downward. So if you look at these notes here, A will reflect it across the x-axis. That's what happens here. So if you flipped it down, it would be here, and then you shift it up. So I'm looking for a negative to be out front of my x squared, and then a +6 at the back. That's the equation I'm looking for. A negative in front of my x squared and a +6 at the back. Right here. So you grab, you're going to drag, and we're going to drop it right here. All right, this other one looks like it has moved to the right 1, 2, 3, 4, 5, 6 units. So I'm looking for a +6. Okay, in comparison, h is what moves it left and right. So since it moved right, actually we want to look for a negative, a -6. That's going to move it right. So I'm looking for a -6 in parentheses here. Well, actually we're going to see a +6. No, we'll say -6 to move it right. So I'm looking for up here a -6. This one, it's going to move it right. And if you need, okay, you can always graph and just verify. Move all of these. You do have that option. If you pull up graphing calculator, let me get everything back. We can graph and verify. So if I go to y equal here, and I can just type this expression in, that would be parentheses x -6 close and squared. And if you graph that, you'll see same thing. So you can graph it as well. We have a graphing calculator, and verify just to check. So now the third and fourth ones, we have absolute value expressions. So let me just go to the parent function again. Absolute value is this V shape, goes all the way across, and starts at the origin, just like a parabola starts at the origin, goes through 0, 0. That's what they have in common, most all these graphs. So once we see the original, we can see what's different. This graph appears to have been flipped down across the x-axis, and shift it left 1, 2, 3, 4, 5, 6. So it looks like left 6 units. So I'm looking for absolute value. What moves it left will be a positive. So I want to see a +6 in the absolute value and a negative out front. So I'm looking for absolute value with a +6 inside and a negative out front. This one right here, we're going to drag and drop. And then this last one, we have flipped because it's facing downward, and looks like we got shifted up 1, 2, 3, 4, 5, 6 units. So I'm just looking for a absolute value, a negative out front, and a +6 separate, because that's how we shift up. And again, I'm just kind of following here. I know shift up, it needs to be a positive, a +K.